in this session, we'll talk about Docker Compose and sharding. Before we go into sharding, we need to give a quick glimpse into how Docker Compose needs to be written first, so that I think you'll all it can be used elsewhere too, not just in this scenario. And so agenda is again discuss Docker Compose in detail, and then we'll talk about the use of volumes in Docker Compose. That is something that you could actually use in your projects as well. Volumes help in maintaining persistence for containers. Containers generally are ephemeral in nature. That is, the data that is written inside into the container, once it goes down, the data goes away too. So you need some place where the data inside the container can lie with persistence. So that's where you use volumes, so that you make the container write data into your host machine, which has like non-volatile data. Now, and then we'll talk about MongoDB sharding as well, and then individual components of the sharding, which I asked you guys to just go through last week, which is config server, query router, and the sharded cluster itself. We will actually build those individual components, and then we'll also learn to shard a collection and also shard an existing collection containing some documents using a shard key. So this is something you can directly incorporate into your project. I will also post the code and commands on Brightspace after this. So, okay, let's get a quick refresher on sharding itself. So sharding is something that we do to distribute the load. For example, in e-commerce websites, you can take, like, let us say that during a particular time of the year, a lot of people are looking for a certain product, and they're going to just, if there wasn't any sharding, they're just going to look for that specific document, and it's going to, eat up a lot of bandwidth. And there is a intelligent way or smarter way to distribute this load, which is distribute these documents into different shards, like which different machines. And like this document 1 I can have in shard 1, and document 2 I can have in shard 2. And similarly, I can just go and distribute these things accordingly. Then there is a strategy that you don't just randomly distribute the documents. There is a certain strategy which you follow, and a key which you use, which is called as a shard key. Shard key is something which you use to uniformly distribute this data across the shards or existing machines based on that concept which I told, which I will also cover towards the end of this tutorial. That is range-based hashing and range-based sharding and hash-based sharding. And there is also importance in selecting the shard key. You need to select the shard key in such a way that it leads to that uniform distribution. Okay, so that's the quick refresher on it. And we will. How do we do sharding? We do sharding by implementing these 3 components, which is first component is MongoS. It's also called as a query router. There is another component called as a config server, and there is the shards itself, which hold your data. Now, the individual functions of these components are like config server holds the data configuration information as to which shard contains which document or which chunk of your collection or database, right? This is the data the configuration server has, and some other information which we'll come to as well. And MongoS is simply acts as an interface to your cluster. Yes, there has to be some entry point into your cluster, and that is what MongoS is. So MongoS is just going to talk to config server, get the, like whenever your day trading app makes a request, let us say to get the stock price of a certain stock, Mongo is going to talk to the config server to get the information as to where this particular stock information is and which shard, and it's going to talk to that shard and get the information, give it. So this way, you are going to distribute the load effectively too, right? And it also leads to scalability. For example, scaling only that specific shards too. For example, in a scenario where a lot of users are requesting for one specific document, you can just scale that specific shard in big data scenarios. So that kind of leads to very high scalability as well as availability. You can demonstrate horizontal scalability using sharding, improving the sharding clusters by adding more shards. We will also look at that. And so before that, so the next sequence of steps that we follow in this tutorial is, we have a Docker Compose for config server, and then we have a Docker Compose for MongoS. We have a Docker Compose for shards, individual shards. We're going to bring up all of those containers within one single network, which we will create, and then enable sharding. on a certain collection too. And you might be noticing that these config servers are in replica mode, right? For example, why is it it's a mandatory thing from now on? I mean, earlier it wasn't mandatory, but from recent updates, it is a mandatory thing, because if config server fails, then Mongo has no way of knowing where the data is, right? As to which shard contains what data. So this acts as a single point of failure. So this always has to be in a replica mode, and it's not even supported if it's not in replica mode. So your config server are in replica mode, even your shards are in replica mode, right? Like even if your secondary of your replica goes away, your data still is there in primary and secondary. And we learned about this replica sets in the last sessions. That's why it was introduced first, so that we can have that concept used here. So that is it. We'll just look at the individual Docker Compose files for these three and try to bring those compose files up, containers in the same network, and then do the clustering. Let me show you the compose files. Okay, let's look at the config server compose file first. So again, a quick glimpse into Docker Compose. Docker Compose is a file that you write for multi-container applications on the single node. Like whenever you want to run different containers, like multiple containers on the same machine, you use Docker Compose file. And it's just a way of telling the Docker daemon what containers you need to bring up. It needs to bring up, and also what commands it needs to run on those single containers, and which network that all of these containers should run in, and all the other details like volumes that they should use, etc. And Docker Compose can also be used in Swarm with Docker Stack node, which I'll give more information in the Slack channel. But Docker Compose generally is an infrastructure as a code file, which you just specify different services that you want to bring up. So in our case, we just want to bring up 3 containers of MongoDB instance and configure each of those containers as a config server. So MongoDB instance can be configured in 3 different ways. One as a config server, one as a shard server, one as a general database. So we're going to bring up the same Mongo instance from Docker Hub and configure it as config server for these 3 containers, and also tell the Docker daemon that they are part of one replica set. Okay, and then we didn't initiate a replica set yet. We are just telling the Docker daemon that it's part of a replica set. How do we do that? We do it this way. Under services, we specify 3 different services, like config server 1, config server 2, config server 3. And we are telling that all of these servers use the same image from Docker Hub, which is Mongo. And once this image is run into a container, it needs to run a command called MongoD -- config server. And then it belongs to a part of a replica set. It runs on a port 27017. And the path to DB is /data/DB. This is what we are saying. We're telling MongoDB that this current instance is a config server instance. It's part of one replica set. And the DB location, you all know that default location for MongoDB is /data/DB. And port mapping, this is host port, and this is the port inside the container. This is not necessarily needed right now, but I'm just mention it anyway. And volumes is the important part. Now, whatever data that is inside the config server will be in this location, as we just discussed, right? This is the location. But this data needs to be somehow written onto the host. That's where you specify volumes. So the left part represents the host, the location on the host machine, on this Windows machine. Essentially, it's not Windows, but yeah, it's the host machine. You specify all those volumes that you want to use in this Docker Compose file here. And then you say all the data within your container has to be returned to this volume, and it has to be maintained. The same level of mirroring must occur. So with this compose file, we are going to bring up 3 different containers, and we told that they are part of a replica set. Okay, and then we'll initiate a replica set. So after doing this, we'll be basically done with config server configured as a replica set. Similarly, we'll have similar compose files for shard1, and we'll also bring up another Mongo instance as a Mongo S query router, which I'll show you. So let's do that quickly. Let's bring up a terminal. Okay. So all we have to do right now is, before doing anything, let's prune any existing volumes, because I have previously run it for other sessions. Yeah, those are the something which I've created. Docker system prune all images as well. Okay. So now we'll create a network for specific, for this particular lab called lab 4. It's a bridge network, then, since we didn't specify anything. And in all of the Docker Compose files that we have here, we are going to specify another element in this YAML file called networks. Under this, we are going to specify the name of it, default type, and name is lab 4. So that all of these individual containers which you are going to bring up as part of different Docker Compose files are added to this network. Okay. So the first step is to bring up that, to use this Docker Compose file to bring up those containers, right? So we'll do exactly that. Docker Compose -f config server slash post up. So Docker Compose up is something which you use to bring up those servers, those individual containers, and add them to this lab 4 network. After this, we just told the Docker daemons inside each container that they are part of a replica set, but we didn't initiate a replica set yet. So we'll initiate that replica set now. Once this is up, we have seen how to initiate a replica set already in the last session. We'll do it. So what we're doing right now is essentially bringing these three things up. Okay. Docker net. Let's get the IP address of them. See, lab 4 has these three containers: 172.18.2, 3, and 4. CFGR1 is that. Okay. I think I already have it. So let's connect to one. -IT CFGSVR1 dash. So we are in one of the containers. We'll get the Mongo shell. And now we'll initiate a replica set. We have seen already last time how to initiate a replica set, which is basically do this. rs.initiate. But important thing to observe here is, we are, while initiating a replica set, you need to provide this element called config server and tell that it is true. And then only you can specify the members. So our members are this, this, and this, for which we already got the IPs. We just checked and we're going to initiate it now. So the replica set is initiated. So what we have done so far, brought these three containers up and we initiated a replica set amongst them. Now next what we'll do is bring shard1, initiate a replica set, shard2, initiate a replica set, and then we'll bring up MongoS. After that, we're going to tell MongoS where config server is and also where the shards are. So we need to tell that too. So let's do that. Let's bring up the other shard1. How do we do that? We have a compose file for that as well. Let me just show you. Yeah. This is the Docker compose file for shard1, server 1, shard1 server 2, shard1 server 3. And if you notice, we are going to run the same Mongo image from Docker Hub, but with a different option called shard server. And we are telling that it's part of a replica set. And we are using 3 different volumes on the host machine and then adding them to the same network. So we're going to do the same thing again. Docker compose. So we're bringing those 3 shards up and also creating these 3 shard volumes. And then now we'll check Docker network. First, let's see what are up. 3 machines are up, 6 machines are up, which is 3 config server. These 3 were configured as a replica set. These 3 will now configure them as a replica set. And how do we do that? We need to get IP addresses of them first. So docker network inspect lab4 shard1 server1 shard1 server2, which is 767 Okay, so let's connect to one of the machines, which is docker exec shard1 server1 bash. Let's get into Mongo shell and then initiate a replica set again, as we did for the config servers. This time, if you see, there's no element there which specifies whether if config server is true. When you don't do that, it's by default a general Mongo shard, like Mongo instance. So that's done. You can do rs.status to see that there are the replica set has 3, one secondary that will just update in a while. Then we'll exit and then we'll bring up. So let's going back to this. What we have done, brought config server, brought one of the shard up. We didn't bring the second one up yet. But what we'll do now is bring this Mongo S and configure it as a query router and tell that config server is at this location with an IP address. I'll just show you how to do that. So we're going to use the same Mongo image from, let's see this first. There's one image Mongo from Docker Hub. We're going to use the same image, which the other Docker Compose files were also using. So what we do is Docker run detached port. We specify it to be 35,27017. And then volume, we're going to use this. This maps to data/db inside the container. And then we also specify this important. Like whenever you're using Docker command, Docker run directly instead of Docker Compose, you can use this switch to specify the network. And then the file. Okay. We should have like everything else and our Mongo S instance. Like this is just a Mongo instance now. We'll have to connect to it and then configure it as a Mongo S instance. How do we do that? We connect to it first. exec t friendly underscore ends dash. Let's see. Okay, Mongo S is fine. So now to configure a Mongo S query router inside this container, which already has MongoDB installed, we just need to say Mongo S, and we are going to specify the location of the config servers. So what we did, we brought up one container of MongoDB, and now we are going to run Mongo S inside that container, specifying the location of this config server. So Mongo S, this CFGRS is the replication set of our config server, the name of the replica set, /, you're going to specify the IP addresses of the config servers. IP addresses of the config servers were 2, 3, and 4, if I'm not wrong. So 02 at port 27017, 0.3 4 2 3 4. Yeah, this, and then you can also specify other details. For example, you can run Mongo S at a port called 27011 because this instance already has a MongoDB running at 27017. We don't want to use the same port, so I'm going to use the new port to run that. Let me check. So I think it is running. So Mongo S seems to be running fine. Okay, so let's bring another. Let that run. We'll just go back again and review again what we have done. Config server this Mongo S we have initiated telling the location of config server, so it's happy now. Our next step is to tell MongoS the location of your shards. I mean, how do you do it? You log into MongoS and then add the location of the shard using the same way, replication set / and the IPs. So we'll do the exact same thing. Docker exec IT. I think it's dash. So how do we do Mongo SH? Local host 27011 is where that was. Mongo S is here. We'll create a database. Let us say shard demo, and then we can do something like this: sh.add shard, and then we specify the replica set name. The replica set we used, the name we used for replica set was shard1rs, right? So we're going to specify that name here again. So let's do that. Shard1rs 172.18.0.5. Yeah, so that shard is added. And if you want to see the state of current shards that are connected to this Mongo S, you just need to do sh.status, and it's going to show you different details. It's showing an array for shards under which one of the member is shard1rs, and each that shard has these three configured as a replica set. So that's the idea. Now what we'll do is we'll bring up another replica set and then make that a shard and add it to MongoS. That's what we're going to do. I have another compose file similarly for shard2 as well. It's very similar to shard1, just the names are changed. So I'm going to do exactly that. Exit from here and do the same thing. Docker compose ceph shard2 docker -compose.yaml up st. Okay, it's bringing those other three shards up. Docker ps. Yeah, so we have these three. These three are done. This is our Mongo S, and these three are new shards, which we need to configure as a replica set. We need to get the IP address of them as well. So Docker network inspect lab 4. This network has so many machines. I believe it should be 9, 10, and 11. Okay, 10, 11, and 12. Yeah, 10, 11, 12. So let's connect to one of the machines. Docker exec IT shard2 svr1 dash Mongo search. And then we configure this quickly as a replica set again. 10, 11, and 12, right? Okay, there's something going on. Okay, it's 9, 10, and 11. So 9, 10, 11. Okay, that shard is created. Replica set is it's configured as a replica set. So these two again. So what we'll do is exit out of here, and then we need to connect back. We brought the second shard up as a replica set, but we need to still tell MongoS that add this to the MongoS and make it a cluster, right? That's what we are going to do again. So docker exec -it just going to quickly do it so that you don't have to see through this perfunctory steps. Host 27011 to connect to MongoS, and then we're going to add this shard. Shard 2, 9, 10, 11 are the IPs. Shard 2 RS is the replica set. So it's added. Now if you do sh.status, we should see 2 shards inside this cluster. Yeah, shards is an array, and it has like one shard consisting of 3 machines, and we have another shard consisting of 3 machines. So total of 6 machines is something that we have. So with this, we have brought up all the different components that are required for sharding, which is config server, MongoS, and then these shards. And this recording will be available on Brightspace anyway after this, if you ever want to go back and see through the process. So the next step is essentially using it for something, right? We have configured a shard, but what to do now? We have a sharded cluster. Now we can create a collection and then see in action as to how the data is moving through these different shards as you insert them, right? So we can do that again by connecting to Mongo shell and using the earlier DB which we have created. This is the DB which we have created. And we'll create a collection first of all. db.create collection. We'll create 2 collections for demonstration reasons. One collection is there. G468T. Okay. Now, before you can shard a certain database or collections within a database, it is important for you to enable sharding on the database. And only if sharding is enabled on the database will you be able to enable sharding for individual collections. It can happen that you can have some collections unsharded. If there is no need for scaling, you can leave some collections unsharded. But if there is a need for scaling for one of the specific collection, you can enable sharding for that specific collection too. So, let's first enable sharding for one collection, which is how do we do it? sh.enable sharding. Before collection, we need to enable it to a DB. So shard demo, we have enabled it to a DB, and we'll now enable it to a collection. So db.seng, no, sh.shard collection. Earlier we sharded a database, and you need to specify the full path to the database. CNG 468. Here it is important. So whenever you want to shard a collection, you need to specify a shard key. As we have seen earlier, the data has to be distributed logically based on some of the element inside a certain document, right? So for example, in our case, let us say there is one element called name. In each of our documents, there is an element called name, which we want to shard our documents based on. Like for example, products in a, let's see here. Yeah, products in a e-commerce website, like each of this document can have a certain name. All of those products could have different names, and they can also have certain names, same names too. Like for example, if doc1 has one specific name and you're hashing that value of the name, then it goes to a certain shard. Similarly, if doc2 has a different name, probably it will go to a different shard. If doc3 has the same name as doc1, then it's going to move to shard1. So this way, it could create a non-uniform distribution if you're sharding based on a key which is not unique, right? You need to select a shard key such that data can be distributed uniformly. So for this purpose, what we'll say is, for the demonstration, we'll just say that there is one specific field called name, and I'm going to use a strategy called hash based sharding to shard this collection. Okay, so now we have enabled it. Now if we can even do something like db dot scng468 dot get shard distribution to see the data distributed across those two different shards that we have. So the shard one, which is this replica, shard two, this replica set, shard one is this replica set. Currently, there's no documents inside it because our collection itself doesn't have any documents, right? So what we'll do is we have enabled sharding on a collection. Now we'll insert documents onto this collection and see how the data gets distributed automatically. So we'll exit from here and then we'll use a small shell script to insert this data. Let's say, yeah. So I'm going to iterate 1 to 50. I'm going to use this shard demo and insert a document called name with varying name into this particular Mongo instance. Okay, so I'm just going to run it. It's going to insert this random documents with these numbers, and I'm going to connect and just check how sharding was done. Use shard demo. Now db.scng468.get shard distribution. Let's see how it is done. So the data was split across 50% and 49.98% was split across these two different shards. And you can even see there are like 4 chunks. There are 50 documents, probably 25 are in these two shards. So that's how sharding can help in real-time distribution of this data, and even read requests can performance of them can be improved further by this concept. Now you may have a question as to what if there is an existing collection which already has documents. How do you shard it, right? So we'll do exactly that same thing. That's why I've created as a secondary DB. We have created another DB, right? Show DB. We have created another collection called scng468. So let's like insert documents inside this and then later try to shard it. So we'll do that with the same shell script. So db dot if we do get shard distribution, it's going to throw an error because we didn't enable sharding yet. So the collection we have a collection which has some data, but we didn't enable sharding. So now if you want to enable sharding, as we remember, we just have to do sh dot enable shard collection. Shard demo dot senng. You have to provide a shard key too, but it throws an error, right? It says that whenever you want to shard a collection which already has been created, you need to create an index with this particular key, because MongoDB by default creates an index on ID, right? So you need to, it doesn't have the data in that form which can easily allow for it to shard. So what you have to do is first create an index on the key that you want to shard, on one of the elements in the MongoDB that you want to shard, and only then you can run this. So we'll do exactly that. db.scng create index, because our key is we want to shard on name, we have to index it also on name. Now name has been indexed, now we can shard it. See, now the sharding has worked. Now, if you want to insert some data, you can just look at db.scmg.get shard distribution. You can see the data being split across shard1 RS. And if you add more data, it's going to split across the other shard as well. So that is how sharding, like essentially you can use something like this within your project for sure. So what I'll do is I'll post all of the Docker Compose files along with the commands which I've just shown you, along with some documentation from MongoDB, so that you can use the sharding within the project. It's not learning curve, doesn't have a high learning curve. And this MongoS is still running in the background, right? So this is something which is enabling all of our commands which we have executed so far. They were only running because MongoS was running. So MongoS essentially acts like an interface to your data rating app. So on your transaction server, you can probably have a client on a Go client, or I don't know, whichever you use. MongoDB offers wide range of clients. There's a SDK too. So just use that to connect to your database which you configure using the Docker. So one more thing I had to specify, because in real time, whenever you were configuring your MongoDB MongoS instance, whenever you were first of all creating MongoS, right? So there you will probably face this issue. So I just wanted to show it right now, which is whenever you're creating MongoS, you're telling the location of config servers, and you're telling the port on which it has to run, but you're not telling which network interface it has to bind to, right? For example, if I didn't provide any network interface here at all, otherwise you can do IP underscore bind. You can specify 0000 to use whatever, or you can use bind underscore all, IP bind underscore all, to bind to all of the network interfaces. So if, for example, you're using CentOS machine, you want it to be accessible from outside, you need to have it bound to a certain network interface so that your client can reach to it. If you don't specify anything, it only take the default host network interface, which may not be accessible. So that's something which is also good to keep in mind. So yeah, so today I think we talked about Docker Compose in great detail. We talked about sharding. We've set up a sharded cluster, and we were able to even create collections and shard an existing collection too. And another request is, whenever you have time, you can just go through this shard key. Probably this will be on your tests, next test or midterm, I believe. So sharding based on shard key, there are different, let me just show types. So there is a hash sharding and range-based sharding too. It's just going to use range to determine the chunks, and this is going to use a hash function to determine which chunk goes to what shard. So there are different functions, hashing functions too, which you can use. So that is all for today. If you have any questions, you can ask. Yeah. In this case, you can essentially, if you want to bring up, in this case, just because for the lab I have created one single network, but in production systems you have different machines on which you deploy them, right? So at that point of time, you may require different Docker Compose, but we can still use the same Docker Compose and use it in a swarm. Like I just showed, like you can use Docker stack node deploy and pass this compose file which has all of the containers, and then it's going to deploy it in the swarm inside the same network. But then you need to think about overlay network too, depending on whether if you have it across different machines or one machine. You can do that. I'll just show that as well. 1 second. There's a good documentation from MongoDB for that. Just posted in one of the groups. So Docker stack deploys a new stack or updates an existing stack, and this is how you use Docker stack deploy compose file. You pass the compose file inside to this, and it's going to deploy it services this way.
Sorry, what is the Docker stack? Is that just like
Yeah, this is a cluster management command and must be executed on the Swarm manager node. Like you need to go connect to the manager and use Docker stack deploy to have your services deploy. Otherwise, you can use Docker service deploy also, like I showed earlier. This is another way to do it.